So to finish up with chapter 4, we're going to take a look at the random class, which we can use to generate random numbers. So the random class is going to be used to create objects for generating our random numbers. So we'll first need to make sure that we import that random class. Just like the scanner class, it comes from the util package. So we're going to have import java.util.random. We'll then go ahead and create an object of the random class. So in this case, we've got our random object that we call random numbers. It will be equal to our new random object. We'll then go ahead and try to create a random integer from it. So an important thing to keep in mind right here is that the random object that we've created, that by itself is not a single random number. That is instead going to be the thing that generates our random numbers. So in the next line where we create a random integer, this is the part where we are calling a method on that object to generate one of those random numbers. So in this example, we're going to use nextInt. So it looks a lot like one of the methods from our scanner class. And this nextInt method of the random class is going to generate a random number within the range of an int. So that means it could be any number from about -2.1 billion up to about 2.1 billion. So let's take a look at this. So go ahead and minimize this. Come over here. We'll go ahead and create a new project. So have a new Java application. We'll click Next. So let's just go ahead and call this one Random Numbers. Click Finish. And so for this one, start by cleaning up the comments and style. And we'll come back to the main method in just a moment. But first, we want to make sure that we import the random class. So that's going to be import java.util.random. And then right here, we'll go ahead and create our random object. So do random. Let's call this random numbers. So basically just name it the same as the class itself, but using that camel case. So this R right here, oops, this R at the beginning is going to be lowercase. We'll say this is equal to a new random object. And then right here, we'll go ahead and create our random integer. So we'll go ahead and say something like int random int is going to be equal to our random numbers.nextInt. Go ahead and save that. And then right here, we'll just go ahead and print that to the console. Go ahead and save it. And so now if we go ahead and run this, it's just going to go ahead and generate a random integer using nextInt right here. It'll store that into random int and then print that to the console. So if we run this, we can go ahead and see our random integer printing out right here. And because of the fact that this is random, every time we run this program, we're going to get a different output for it. So right now we got this roughly -1.4 billion, it looks like. So we run this again. Now we get about -2 billion. Run this again, and now we get about +2 billion. So because of the fact that the range for an integer is so large, it's going to be pretty all over the place. One of the interesting things you could do then is to just go ahead and take these two lines that you have right here, just put those into maybe a while loop of some kind, or a for loop. So maybe we should go ahead and take this line right here, where we're generating our random integer, and then this line right here, where we're printing that to the console. We could put that into a for loop. So we'll say something like for int count equal to 1, count less than or equal to 1,000. So we're just going to go from 1 to 1,000. We'll do count ++. And then we'll just go ahead and take these two lines, go ahead and cut those, put those into our for loop. And so now, if we go ahead and take this code that we have right here and we run this, what it's going to go ahead and do is just repeat this process 1,000 times and just generate 1,000 different random numbers. So if you go ahead and run this, you're going to see all kinds of different random numbers being printed out to the console. So if you scroll through this, you can see all of the different random numbers that it generated for you. So in addition to the nextInt method, there's going to be a couple of other things we could consider. So one of these would be to limit the range of random numbers. We can provide an upper bound that's going to be passed into that nextInt method. So in this example, we're going to pass in the upper bound 100. And what that's going to do is now limit it so that the range for our random integer is anything from 0 to 99. So it is very important to keep in mind that the range is always 0 all the way up to the passed in number minus 1. So if you give it 100, 0 to 99. If you did something like 10, that would be from 0 to 9. So let's consider an example like that. Say we minimize this. We'll come over here. Let's say that instead of just generating any random number, we generate a random number with the upper bound of 20. So now it's going to be anything from 0 up to 19. So if we go ahead and run this now, it's going to generate 1,000 of these different numbers. So go ahead and run that, and now we see all of these different values printing to the console. But if you take a look at this, this is 1,000 different printouts, and not a single one of these is ever going to be greater than 19 or less than 0. In addition to that, it's also going to include things like the next double, next long, and next float methods. The next double and next float method will return a double or a float respectively. Specifically, they're going to be within the range of 0.0 up to 0.1 or 1.0. So essentially, it's going to be a decimal number. The key difference is going to be the degree of precision. So again, remember that floats have something like, I believe it's 7 for their precision, so up to 7 decimal places. And then doubles have about twice that, so they go to 15 decimal places for their precision. So that'll be the key difference if you use one of those two methods. And then the next long method is going to return a random long, similar to the next int method. But one thing to note about these is that only the next int method can take a value like this upper bound that we just showed. All the rest of them are just this construction that doesn't take any arguments that we see right here. But we can go ahead and take a look at each one of these as well. So go ahead and minimize this. So let's say we come over here. Let's go ahead and comment out this guy for now. And let's go ahead and create, let's actually comment both of these out. We'll go ahead and create a couple more different examples. So let's say we want to go ahead and do one with next float next. So we'll go ahead and do a float, call it random float. It's equal to our random numbers dot next float. Go ahead and save that, and then right here we'll go ahead and print that to the console. So system.out.println. That's going to be a random float. Go ahead and save that, and if we go ahead and run that, so it's going to go ahead and print out each one of our different numbers. I think so. It looks like some of them can actually go up to 9 decimal places, a little bit larger than I was expecting. But yeah, this will be the general idea for random float. But if we take a look at next double, then the precision should be a little bit larger if we can get particularly precise numbers out of it. So it looks like 9 is about the limit on that one. So this one will be random double. This one, making sure the data type is double. So I'll go ahead and say this is equal to our random numbers dot next double. We'll then go ahead and print this one to the console as well. So do system.out.println, do random double, go ahead and save that. And if we go ahead and run this one, so you can see now the precision for these decimal numbers is much larger than what it was for the previous one. The number of decimal places that it will take it out to is going to be much more exact. So that's the key difference between those two methods. And of course, also what you'll notice with both of those methods is that they're in that range of 0.0 to 0.1. So every one of these is some kind of fractional or just strictly decimal number. We'll go ahead and comment both of these out. We'll take a look at one last one with next long. So right here, we'll go ahead and do our long, call it random long. It's going to be equal to our random numbers dot next long. And then we'll go ahead and print this out. So this is going to be very similar to when we did just next int without this upper bound, where it gave us any random number within the range of integers, so anything from negative 2.1 billion to 2.1 billion. In this particular case, we're going to have to take into consideration the range for a long, which is much larger than it is for an int. So if we go ahead and do this, save it, we run this, you're going to see that you get much, much larger numbers when you use this method. Okay, so at this point, this will wrap up everything for our random number generation with the random class. Pretty short example of how to use this class. For the most part, it's pretty simple and pretty straightforward. And at this point, this is going to wrap up everything for chapter 4.